अस्सलाम सर।
वालेकुम अस्सलाम।
सर आपने 3 days के क्विज को 2 days के क्विज पे कर दिया।
3 days के क्विज को
तो आप पहले 3 क्विजेस ले रहे थे ना, तो अब आपने हमें मंडे और वेडनेसडे का सिर्फ टाइमिंग बताई है।
एक ट्यूसडे को कर लेंगे।
तो थर्सडे को कर लें।
सर ट्यूसडे को नहीं कर ली। सर ट्यूसडे को पहली बहुत क्लासेस हैं और थर्सडे को भी। सर फ्राइडे को कर लें।
फ्राइडे को करने हैं तो कोई इशू नहीं, लेकिन एक मेरी क्लास का वाइवा है, वो बस डिस्टर्ब ना हो, और तो मुझे कोई इशू नहीं। चलें, लेट्स सी, फ्राइडे को कर लेंगे।
सर दूसरा, आप क्विज की टाइमिंग आपने 4 to 6 रखी हुई है, सर आप 3 to 5 नहीं रख सकते?
एडजस्टेबल है, वट एवर इज कन्वीनियंट टू यू पीपल, मैं उसको सेट कर दूंगा, देयर इज नो इशू।
ओके सर, फिर 3 to 5 प्लीज रख दें।
3 to 5 चलें, 3 to 5 कर लेंगे, कोई इशू।
थैंक यू सर।
यू आर वेलकम। Okay, let me open the data sheet, then we will start.
Sir, we'll be having relative marking, right? And sir, can you please share the like our marks in the previous quizzes and assignments?
Exactly, I will share, don't worry. On the last class, I think.
Okay, sir.
On Friday, right? So it's better to have all the quizzes before Friday, so you can observe, or it is also possible that you can observe all your results on during the Viva, because one by one every student is coming, so every student can get his or her marks. So both options are available. Let's see. Okay, first of all, we were discussing about this linear regression. So I hope that you already know how to convert a generic form of functional relationship into an equation form, and then you need to solve it. And after solving, what is the purpose of solving this? Just to find out the value of these coefficients, constant and parameters, because they are helping you to drive on the one side the relationship between given variables, as well as you can use it for some forecasting purpose. One important thing we have learned is the deviation from the actual value. Whenever you are making some estimation, and then your estimation may not be 100% accurate. So how much percent variation exists, basically it shows the residual. It's not going to be taken in percentage, but just I'm giving you the hint. More the deviation, more the problem. If less deviation, you can have better results, specifically whenever you are going to make any forecast. Okay, then I have mentioned to you regarding different type of models or different type of relationship between different variables. So the basic theme is that you need to actually capture the relationship in a more effective way. So whether it's non-linear, then you have tried to convert it into linear form. If through log it is possible, then it's more than desirable. But if after taking log, even your relationship is not going to be linear, this means in that case, log formation may not convert non-linear relationship into a linear form, and you cannot apply simple linear regression. In that case, you have to go for some kind of non-linear regression. So different kind of limitations you are going to face. So you have to resolve these limitations accordingly. Just purpose is same, that you want to actually get the relationship between different variables so that you can make an effective forecast. So last time we have discussed about this data set, and we have calculated our results just like in our sheet. You people have tried to do that, because you people are desired to do and follow it. Gee, any one of you have done this? Incorporated this data set and tried to resolve it through this the formula, this line estimation technique. Any one of you have applied this technique? Gee, I need your
Sir,
response.
for the yesterday's data set,
No, you are this the data set
the
which we
last class.
have used in
Yes, sir, I
discussion.
did.
This one.
So we had to write the slope, the SC slope, the R square, the F stat.
All of you people are required, actually. You have to do this. You have to do this practice, because once you are going to make this practice, then if I'm going to share some data set with you, you can apply it and you can run the regressions and you can derive the results. And after derivation of the results, actually your job is going to start. It's not doing these calculations, doing these regressions. Basically, the purpose of learning this is that now all kind of statistical softwares are available, and they are helping you to generate different kind of results. So there's no problem in terms of doing these calculation, because now they are just on the click of your fingers. So few clicks will lead to generate some results. Actually, your job starts and you need to interpret the results. And this is the most important thing you have to learn. Therefore, I have given some of the questions to you related to data set in the assignment, and some other questions have the results. I don't know whether I have given these questions to you for practice or not, but whenever you are going to generate the results of your own data set or whatever assignment questions data set is mentioned there, then actually you are going to interpret the result. So this is the most important thing. The relationship between y it is y hat, and whenever you are going to place some values of x1, x2, x3, you will get the result of y hat, and that is the estimated value. It may be exactly the same whatever actual y value exists, or it may be different, but the deviation is going to be minimized because you have applied this least square regression analysis, right? So anyone can explain this result or this phenomena? What is going to be represented by this? X1 is just like what variables we have used. I'm just going to make sure. X1 is mentioned as temperature, mean temperature, X2 attic insulation, and X3 age of furnace. So there are three things: temperature, attic insulation, and furnace, age of furnace. So what about this temperature? How temperature is going to affect your this heating system or heating cost? Actually, this
So
is heating
it's
cost,
the
right?
cost of heating system.
Hmm.
It will affect negatively. That means that if the temperature is high, we have to pay less for the heating system.
Because actually problem is the low temperature. If temperature is moving down, then you have to arrange this heating system. Otherwise, rising temperature is not creating any problem. So it is resolving your problem in reducing your cost. So the impact is 4.58 for 1 unit of 1 unit of temperature change. In case of this second, it is the attic, and attic is playing vital role. So it is more important than the even furnace age.
Sir, it's insulation.
It's attic insulation. So insulation,
Yes,
if
sir.
more insulation is there, just like if the size of this attic is small or the gap is small, just like this is the house and this is the attic, which is placed there, and this is another house and this is the attic which is placed here. So the gap, more the gap between this attic, more it will work as strong insulation, and smaller the gap, it will work as poor insulation, right? So the point is that insulation, more insulation is needed. So if you are going to impose better attic, more area, then definitely your cost will reduce significantly in a greater magnitude, right? But if it is smaller, then definitely the cost is higher and higher. This attic is measured in terms of insulation inches, right? So attic insulation is inches. So even inches are going to play vital role. 1 inch, and this shows that 1 inch change is having this much impact. But since we are using these variables in terms of level, so we can say 1 unit cost will rise with 1 inch increase, 1 unit cost decrease with 1 inch increase in insulation, attic insulation. If 1 inch attic insulation reduces, then definitely this cost is going to rise. Age is playing some important role, but you know that plus sign shows increasing age will rise more cost. So older and older this furnace is getting, so much cost you have to bear. And usually you know that, let's suppose if the furnace age is only 10 years, so actually it is measured in terms of years. So after 1 year, furnace age is going to be depreciated. So second year, third year, and ultimately you have to replace it. So therefore automatically cost of maintenance is going to increase as well as replacement is needed. Any value or for any kind of forecast, let's suppose some person is going to buy a house and he calculate the temperature, what is the temperature, then he calculated the inches of this attic, and then he find out the furnace which was placed there for heating system, age of this, and place the value, and then he has calculated the cost of heating system. So this actually equation is quite helpful for any kind of house. Whenever buyers are going to buy any house, whenever they are going to apply this regression analysis, they can make some kind of estimation or forecasting about the heating cost. But it is not essential that exactly the same value you have to bear, just like, because it has some standard deviation. So keeping this point that how much standard deviation, how much lower value, and how much, let's suppose if 10 units standard deviation is there, it may be 266 and it may be 286, right? So okay, I just make it 10 standard deviation, right? 10 unit plus 10 unit plus 1 standard deviation is 10 unit plus, and 10 unit, sorry, 10 unit plus should be higher, right? Because it is going to increase, it should be 86, and this should be 66. And this should be minus sign. Is it clear? So whenever you are going to report your results, you are mentioning some kind of standard deviation, even that how much standard deviation is possible in your calculation, so that you are going to give some range. So usually that range can be obtained through the interval, whenever you have some confidence interval, right? So you can use that confidence interval, just like we have calculated that in our calculations. So in this case here, it is not available, just like the confidence interval is not calculated here, right? Because this formula is not giving you some confidence interval. But whenever we have applied some other statistical tool, we will get the confidence interval for that. And otherwise, you can calculate that confidence interval by applying this formula. First of all, you have to calculate this multiple standard error of estimate. Actually, this standard error of estimate is already given the result. So you already have these standard error of estimates, right? These standard error of estimates are there, right? I may make it bold. Right? So these are already given. So you need not to calculate, but what you need to do, you can apply this to calculate your confidence interval, just like it has been done here. They're giving you the I think calculation is not given here regarding for a confidence interval. Just like previously we have applied for simple linear regression, so the same you can apply for this multiple linear regression, right? Okay, then there are some assumptions which are important to be considered whenever you are applying multiple linear regression. The independent variable and the dependent variable have a linear relationship. So this need to be clear beforehand. If there's no linear relationship, then you cannot apply linear regression. Only one thing is there, you can modify, you can change or reform this model and try to make it linear. Just like we observed that previously some data set we have used and no linear relationship was there, and then what we did, we take the log and it becomes linear relationship. Right? So in that case, you can apply this linear regression, otherwise not. And just like in our case, seems that data should have some kind of linear regression. Let's suppose if we find out data points. This is the limitation. Actually, whenever you are going to pick charts, specifically you go for this, pick only two variables at a time, and then go for all charts where you will find XY scatter, and there on the right hand side there are two, but in this graph both curves are there, and X and Y axes are different, series are separately mentioned, but in this case axes are placed, right? So you will okay this. Once you will get this, it means on y-axis and x-axis, basically these two variables are being used, right? So you can observe the relationship by just moving the data set. Now, what I'm going to do actually just want to show you what is happening, whether the data set is showing any relationship, linear relationship or not. G, is there any linear relationship? Straight line linear relationship.
सर वेल यहाँ पे पॉइंट्स तो
start
इधर जा रहे हैं लेकिन
थोड़ी सी linear relation, but at the end it becomes too spread out.
A relationship in inverse, but still it's not so much linear, right? So it's not so much linear, it has more deviation. If I'm just going to add other variables, what will be the picture? Let's suppose these variables have a bit linear relation. It seems that they have better. So just like if I'm going to move there one by one, let's suppose this is the furnace age, right? So furnace age with reference to heating cost. What kind of relationship it shows? Again, it's not so much linear, Hana. So the point is that whenever you are going to observe that relationship, whatever line you are going to draw, you have to take care. So both options are available. If you go for log formation, then you can also find out the relationship. So in this case, again, it's not so much linear. Clear? So what we need to do basically, what do you think? What is most suitable in that case? Should we know, should we apply this? Actually, I'm just going to apply log relationship. Okay, I'm just going to apply this one, creating a place. Okay, Let's suppose last time we have applied line estimation, but now we try to apply log estimation, log line. It's line log, right? Line estimation, log estimation, LOGEST. Log estimation, right? So you have to click this one. Then you have to pick the Y's. So this is the cost we are going to take. So we are going to compare the result after taking this log. Let's see the results are getting better or not, right? And it should be better because just like I will show you after taking the log of these values, and then we will find out what will happen. So now I am not going to take the 21st value, right? Because that is just like forecasting. So we will do it later. Okay, this and then one and then one and close, and then you paste Control Shift Enter. Oh, sorry, I didn't select the whole area that need to be selected. This is the most important thing which we need to do because the calculations will be made.
Sir, excuse me.
Please.
Sir, excuse me.
Did you please?
Sir, last time when you were writing the numbers from the range, now you added 1 and 1 twice. Why were you adding 1 and 1?
Okay, I'm just going to do it again. So you will observe this. What is the meaning of this one? Okay, first we are going to take Y values. Right, and then we are going to take comma X values. It will create log by itself. Clear? Okay, now your question. One for the constant, just like it is written constant. So you want to include constant alpha or beta naught. Definitely we need to include constant, or sometimes you can skip that. There's no issue. You can place 0 if you don't want to take it. And then you need to find statistics, right? So return the additional regression stats. Otherwise, you will only get the regression equation, right? So just we want to have complete results. Therefore, we will place 1 for stat. After that, you will go for this, right? Control Shift and Enter. You will get the results. Now, what has happened with these results? I'm just going to make it bold, and then I'm going to make it colored. Okay, no need to color, but anyhow, can be used this way. Okay, now this equation has been changed, right? Now you can observe by yourself this is the intercept. Its a value has increased a lot, and then why these values are low? Because all these values are taken in form of log. So you can convert it back into anti-log, and then you can have original intercept values. It may be this one or it may be different, right? So this is giving you better idea. And just like last time, I have used to calculate t statistics for this. I think this is the t statistics. Calculate t statistics. T stat. So same we are going to calculate here. T stat. Sorry. And it can be equal to your beta variable divided by standard error. Enter. And now you can observe one important thing. If you observe here, what happened with the t values? What happened?
So they're very large.
They are so much large because now it's highly significant. Relationship become more clear. It become more linear. Now I'm going to show to you on this graph. Just like we have used these values in form of, just like I'm going to copy this first on some other sheet quickly. and then I'm going to generate this is estimated. Okay, we'll do it later. Here we can take this. So I'm just going to move this here, and we are going to copy it. And then we are going to take this equal to log bracket this much amount, close, and then you scroll it up. So not estimated, right? And then you scroll down. Okay, you will get all these values in form of log, right? And then I'm going to apply again another. Sorry, I'm just going to pick two variables at a time, and then I'm going to insert again these recommended charts, all charts, X, Y, and then you will go this. Okay, right now two variables are being selected. No, it's giving series separately, so this is not correct. But it need to be properly XY, because otherwise you will not get proper results. So again, I will try to insert some limitation we have in terms of these charts. Oh, good, we got this chart like this one. No, it's not giving us that one which we need. It is giving us, actually it is not considering this now, it is considering this is the chart in the mean to say it is a continued data set, so it's not giving us. I mean, okay, what I can do is that we know that these are the log form value. We already have original data set, so I'm just going to copy it and just going to paste values only right here, right? So I'm just going to delete this. So it should be delete. Okay. Actually, arrays there down all is selected, therefore it's not going to delete all this. It can only delete here. We can delete it in this way. Okay, now what happens if you observe the data set with reference to this is taking, well, not this is not taking these values, this is taking some other values. So now we can try to apply insert mandate chart, all charts, area, not giving us. Okay, we can apply this one. We have this diagram here now, so okay, we can delete it. Cut. Now we are going to take values on this page, insert recommended charts, all charts, and then we have area over. It's not giving us scatter chart properly. Okay, it's not giving us in this way, so we have another way to handle this situation. Just going to show you that how much data has changed due to taking log. Some limitations we are going to face in terms of this. I'm just going to paste these values here. We have selected all. Okay. Here, right? Now, if I'm going to take this one, and now I'm going to take this one, a bit closer picture. I'm going to move this and only this one. Now you can observe cost, which is now cost is there, so it is not going to be mentioned. This is the relationship. Now relatively it becomes closer, these values, right? With reference to this cost, mean temperature, previous situation is a bit different. Just like you can compare both. This is this mean temperature, and then this is the mean temperature, right? This data set and the data set I have shown you, just like if we are going to do this, you can have better picture. You can hide it, and then you click this one, and then you can observe this. This green line shows that now it's showing more linear. If we are going to remove this upper selection, then these green lines become blue, and it shows comparatively low gap between values, so it become more linear as compared to other, right? And same applies with this. So all these values are there one by one. You can observe now the data spread is going to be reduced. Actually, it can be more clear whenever we are going to apply some other software, and then you can observe that changes. Just like if I'm going to copy it on eViews and do that, then definitely you will observe more clear picture about it. Anyhow, purpose is that you already know that how data set is going to become more linear whenever you are going to take the log form. Clear? Okay, residual must be the small for all values of y. When this is the case, we say the difference exhibit homoscedasticity. Okay, what is the residual? Same for all values of y, right? Now this residual is actually that value which we need to calculate in through estimation. Just like if we come back and we are going to unhide this, right? And then we need estimation cost. Then we can apply the formula. Last time I have given you the idea that you are going to apply this value of your formula. You have to, now you can apply either, you can apply this log formation or you can apply this one. In case of log formation, you will observe results are better compared to non-log formation. So first we are going to apply non-log formation. So this is your coefficient plus beta 1 multiplied by x1 first variable, which is mean temperature, plus beta 2 multiplied by x2 second variable, plus beta 3, and this is multiplied by this third variable, which is Fernand's age, right? So all these variables are going to be incorporated, and then you have calculated this estimated cost, right? So first you calculate this estimated cost, and please do one thing, make these values fixed, because through F4, whatever values of coefficients we have taken, these must be fixed. Only this thing need to be taken care, then your results are not going to disturb. Otherwise you will get such kind of results. Okay, and then let's suppose if I'm going to do or find out. Okay. Now this is the problem that we cannot generate here any cell. So I'm just going to use estimated values, the error residuals, which are going to be calculated here. And these are equal to what? Residuals are the difference between y hat, actual y value, and y hat, right? So I'm just going to write down for your convenience, residuals are equal to y minus estimated y. And what is y? You can also mention that it is just like h cost minus estimated h cost. Before the time is getting over, I just want to make sure that you will get this result. So equal to this h cost original value minus this is estimated value, enter, and then you have to take the square, otherwise these values plus minus values will be cancelled by each other. So power 2, enter. So you will get this one. These are the residual sum of squares which you will get, right? So these are the residual sum of square. So if you are going to find out these residuals, Just like what is the graph of these residuals, you can observe it by observing this, by inserting this graphs, simple chart, line chart. So these are the residuals. Right? So these are the residuals. Now these residuals are showing the variation, right? And these variations are quite away from zero. So quite large variations you will observe in this case. And let's suppose if we are going to apply the same residual, same strategy only for this. Now for log model, log model, and then we can apply this equal to, first we need to calculate log model estimated value. So estimated H cost, and I will use log estimated H cost, then equal to same formula you are going to apply, but just like you have to change the variables of these, just like this, these are the variables. So first plus, kindly make it fixed as well by F4, right? Then plus second variable, second coefficient. I'm just going to make it, multiply by, before multiplication again, you know, F4 is essentially required. Then multiply by your first variable plus then second coefficient, F4 multiply by your heating cost, sorry, this attic, plus the third parameter, this one, F4 multiply by furnace age, right? So enter. Now you will get this result, and now we will try to observe how much change happens in the variation of this data set. Now I'm going to show you the diagram curve, right? So now you can observe the variations, right? The variations has been changed. Now they are quite smaller in terms of their total size, right? So since their intercept is larger, therefore it starts from this value. In this case, the intercept was lower, so it starts from some smaller value, because in both cases the difference comes due to the intercept. Intercept is 920, so it will start at higher level. It intercept is 427, so it will start at lower level. Is this clear to everyone? Because the time is getting over, only 1 minute is left. So we need to rejoin, or we need to rejoin so that I will take your attendance. Or if you have any query related to that, that can be solved in the next session, right? Mean to say after this time is over and we are going to reconnect. Clear to everyone?
Okay, sir.
You people will rejoin, right? Once it is going to be closed by using the same link. And I will actually upload the recording of this session, but not the next one, because in next session we are just going to take the attendance, as well as we are just going to discuss any of your query. So that need to be resolved. Clear? Okay, one thing is totally obvious or clear, that the variation here are larger and the variation here is smaller. Okay, I have just like find out the, okay, we need to calculate the residuals. Actually, these are the estimated values, and first I need to cut this. Okay, this is the model actually, and now we need to apply